Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos.
Right, so let's have a look at some of the rules of logs in this session. So they're on the same page that we were using for indices. Indices are here on the left, and then logs are in the center and here on the right. Now, logs are the opposite of indices. So you can see when you look at the log tables that they kind of have similar rules beside each other, and they've done that deliberately. So in other words, if you get the log of a product, you can break it out into two individual pieces. So for example, if I was getting log to the base a of 32, I could break that into log to the base a of 8 plus 8 fours are 32, log to the base a of 4. Okay, so it's kind of the same as what's here. If I had two products, I added the power. The division one is the same. So again, log to the base a of 40, for example, could be written as log to the base a log to the base a of 4, sorry, could be written as log to the base a of 40 minus log to the base a of 10. Okay, the third rule down then, when you've got power to a power, so there's a similar rule in logs. When you get log to the base a of x to the power of q, you can bring that power down in front, okay? Or what you end up doing in a lot of cases is to bring that value that's in front up to make it a power. Okay, in indices we had a to the 0, a to the power of 0 was 1. In logs, log to the base a of 1 is 0. So log to the base to any base of 1 is 0. Okay, and then the reciprocal rule, there's a similar one in logs, but the minus comes to the front. Okay, so we'll practice those in a minute. The ones on the right, then I'm going to do first. So the top one here is often called the switch. It's where you switch from indices to logs, and it's very important you're able to do that. These two rules, some schools don't use them that much. I happen to think they're extremely useful and really easy to use, so I will use them a lot. I tend to use these more than I use the switch. And then this one down the bottom is what we call changing the base. Okay, so just like in indices, it was important that the base number matched. In logs, this is your base number here, the little b or the little letter that's written beside log. When you're manipulating log questions, they have to have the same base number. But thankfully, we have a rule here that will allow us to what we call change the base to something. But initially, I'm going to copy these three up here. And we're going to work a little bit with these ones. Okay, and like I said, we're going to end up using them all, but these ones. So how do you use that first one here? How do you switch from indices to logs? Well, if I take an example, so let's just take one example, and I'd say maybe write using logs. 27 is 3 to the power of 3. We know that, okay? But what if the question was 27 is equal to 3 to the power of x? Solve for x, okay? Now again, because this one is easy enough, you might be able to see the answer, but how do you do it using logs, okay? This is why you need to be able to what we call change from, do the switch, change from indices to logs, because what you'll find is if you get the log of a number, you actually get the power. Do you see that? So the log of a number is the power to which the base must be raised to give that number. Okay, let me say it again. The log of a number, so the log of y, is the power to which the base must be raised to give that number. Okay, and it's one of those sayings that if you learn off, you will, excuse me, you will remember what logs are for. Logs of a number gives us the power. So you know you need to use logs when what you need is in the power. Okay, so let's do the switch. Okay, so you map the letters. So this is your A, this would be your X, and this would be your Y. Okay, where did I get them? I just got them here, and now I'm going to write them using the rules of logs. Okay, so that's equivalent to log. Okay, your base number in logs is the base number to which the power was raised. So it's that little 3 there. It's the log of your answer. So it's 27. And that would give me my power, or would have given me X in this one. Okay, how do you put that into your calculator? Well, you've got to be careful because the log button in your calculator, that log button, it is on mine, the Casio FX83, it is under X to the -1. Okay, the reason you have to be careful with that button is that is automatically programmed for log to the base 10. That is one of the most commonly used logs out there. So it has got its own button on the calculator. In a similar way, just to the right of that is an LN button, and that actually is programmed as log to the base E. It's the natural growth rate of a lot of natural phenomena in the world. So it is, again, given its own value. E has a value, it's a constant, and it's given its own button on the calculator. So the one you need to use if you are not using log to the base 10 or log to the base E is this button here. So log to the base, and it's colored in, and an empty box. Okay, this allows you to enter any base number, and then of course the second box allows you to enter what you're getting the log of. Okay, so that's the one you need to use if you've got a base number that is anything out from 10 or E. Okay, so really important, that is the only one that allows you to put in your own base number. Okay, so just to try that, if you put in your own base number on that log button I just described, you'll see you'll be able to put in 3 as the base number, put in 27, and you should get the answer 3 like we did here. Sorry, wrong button. That one. Okay, so you have to be able to switch quite niftily between indices and logs. Okay, and just map the letters for a while, and then eventually this will make sense as well. Okay, so that's the switch. I'm going to do another one of the switches. Do you know what? I'm just going to make one up so that we can really see it. 108 is 2 to the power of X. Okay, solve for X. Okay, or let me even write it the other way around, which would be more natural for us. 2 to the power of X is equal to 108. Solve for X. Okay, so not so easy in this one to do it in your head. Okay, so this is where logs again comes out on their own. So again, I'm going to map the letters. A to the power of X equals Y. And then write it using the log. So write it using this side now. Log to the base A, which is 2 of Y, will give me X. Okay, and into your calculator, hit that log button, enter in the base 2, enter in 108, and you can see that you get an answer of 6. We'll go 3 decimal places, 755 for X. Okay, so there's no way you'll be able to do that in your head because it's not a natural number. Okay, so this is where logs comes out on their own. You use logs when what you need is in the power. Okay, now I'm also going to use that same example to explain the next two rules of logs that I have there, okay? So I'm going to again use the same equation. 2x is equal to 108, solve for x. Okay. So remember I said logs and indices were the opposite of each other, okay? Well, you'll see that in action here. So just the same as x squared was equal to 16, we do square roots and they cancel as well. Okay, logs and indices, all the opposite of each other as well. Okay, so how do they work? Well, when you have something to a power, okay, and you get the log of that with the same base, these cancel. Okay, because log to the base a of a is equal to 1. The log of itself is 1. Okay, and in the same way, a to the power of log a is 1. Okay, so these end up cancelling each other out, and that's how you have your answer being equal to x. Okay, so again, how do we use them? So let me show you in this one. So 2 to the power of x is equal to 128, okay? So if I go log to the base 2, so what I'm doing is I'm matching the base number here to the base number of my log, okay, of 2 to the power of x. Okay, so all I did was add in log to the base 2 and I picked my base number to match the base number here. Okay, what I do to one side, I have to do to the other. And the 2 and the log 2 cancels. And I have x is equal to log to the base 2 of 108, which of course is what we had up here. Okay, so 6.755. So again, yet another way to solve a log problem, but using this rule instead. Okay, so very similar outcomes. One is not better than the other. People just have a preference for doing the switch or cancelling out like here, and it doesn't matter which way you do them. You have to pick your preference. Okay, now let's do it in reverse. Then let me just copy over these three rules again. Okay, a bit crooked. Okay, let's have a look at if we're given logs and we need to solve them. Okay, so log to the base 27 of 3 equals what? Okay. Well, let's just see. Let me put an X in there rather than a question mark. Okay, let's see if we can do the switch here. Let's see if it makes sense. Yes, you can just put this into the calculator, no problem at all. But just for the purposes of practicing the switch, can we do it here? Okay, so now I have, this is my A, this is my Y, and this is still my X. Okay. So I end up getting 27 to the power of what gives me 3. Okay, so again, written like such. Okay, then let's solve it into your calculator. Use your log. You can't solve it from here. You have to solve it from here. So again, put in your base 27. And you can see the answer is a third, okay? Okay, much easier to see that I think much easier to see that you're going to get a fraction for it here when you consider it as indices, because obviously this number is smaller than this number. So that's not even going to be to the power of 1, because 27 to the power of 1 would be 27. So it makes sense that you're going to get a fraction when it's something like this. Okay, so we will take another example where we go log to the base, and I think I picked 5 of a number equals 12. Okay, now in this one, you can't put that into a calculator. Okay, we could put this so it was easy enough to solve. That you can't put in. So you have to use one of these little tools here to be able to solve this one. Okay, so again, if we practice the switch, we're going from the log side, the right-hand side this time, back to the power side. Okay, so label it. There's your A, there's your Y, there's your X. And then just rewrite it using indices, and then you'll be able to get it into the calculator. So my base number, your base number in your log becomes your base number in your indices. So my base number is 5. Okay, your answer to your log, so the log of a number is the power, that becomes your power in your indices. So that 12 here, your answer to your log, becomes your power. Okay, and then the log of a number goes out there. Okay, and 5 to the 12 you can put into your calculator. I used 15 when you didn't hear me, so apologies. That's how good my memory is. I can't remember. 244140625. So it's a huge number. Okay, and again, no way you would do that in your head. Okay, but it's this skill of being able to switch between logs and powers that's important. Yes, they're given to you in the log tables, but you need to practice them to be able to use them. And once you get that switch and that relationship between the two of them, logs becomes a little bit easier. Could I solve this using one of the bottom two rules? Yes, I could. Okay, so log to the base 5 of x is equal to 12. Okay, it's the bottom one I use this time, and I use the fact that if I use the same base number and I raise everything up by that, these will cancel to 1. Okay, so what does that mean? Well, it's this base number that I use, and I go 5, and everything is raised up like that. Okay, and what I do to one side, I must do to the other. Okay, so 5 becomes the base number and everything else becomes its power. Okay, why? Because log to the base 5 and 5 cancel. So just on the left, then you're left with x, and you have to, I suppose, suffer the consequences of the right. Okay, but you can see you get 5 to the base 12 just like we did above, and we're going to get the same answer. So again, it's whichever one you prefer, the switch or these two here. Okay, I'm going to give you one or two to practice just to see how you get on. We will do these types. So the first one is log to the base 2 of 17. No. Let me put x is in there is equal to 17. And then try this one, log to the base 3 of x being equal to 50. Okay, so I'm going to pause now and give you a chance to do them. Okay, let's have a look at these. I'm going to use, you can use the switch, no problem at all. I'm going to use the bottom one just for something different. So it's base 2. So if I raise everything up like such, the log 2 and the 2 cancel. So x is equal to 2 to the power of 17. Let me just put that into the calculator. It's 131072. Okay, and the same way over here, my base is 3. So if I raise everything up by 3, and then I get a huge number here. by 10 to the 23. Okay. And you can see from these numbers, and I deliberately picked two numbers as such, okay? Logs has been around for a few hundred years and was specifically brought in to cope with big numbers, okay? Especially the base 10 one. So when you're graphing, when you're looking at graphs of really big numbers, maybe 0 to 1 million, if you think about that for a minute, you have too many points on your x-axis to plot if you were going to go up in a million. So what you end up doing is doing a log graph, and you go up in a logarithmic scale. Okay, so you're going up in 10, 100, 1,000, and so on and so forth. Okay, a base 10 scale. So that's where logs come out on their own, where you're dealing with big numbers.
If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.